Hello. In this video, I'm covering the last section of chapter 1. So that's section 1.8 on absolute value equations and inequalities. Okay, so let's read what the absolute value is. Recall that the absolute value of any number A, written A within bars, gives the undirected distance from A to 0 on a number line. By this definition, the equation absolute value of x equals 3 can be solved by finding all real numbers at a distance of 3 units from A. So you can see the absolute value as a distance of, of a value of a number line from 0. And in general, if A is positive, then the absolute value equation, absolute value of x equals A, has two solutions. So those are going to be the opposite of A and A. So you have on a number line, you have 0, and you have some positive number A. So the distance from both 0 to A is the absolute value of A, and the absolute of the distance from 0 to the opposite of A is also absolute value of A. In general, an absolute value equation has to separate solutions, or has to separate equations, each of which must be solved. Okay, so let's solve. The absolute value equation, 2x, absolute value of 2x minus 1 equals 5. So this absolute value equation will result into separate equations. If the absolute value of 2x minus 1 equals 5, either 2x minus 1 equals the opposite of negative 5, or 2x minus 1 equals 5. And we know how to solve these equations. 2x minus 1 equals negative 5. Add 1 to both sides. So 2x equals negative 4. Divide both sides by 2, and x is negative 2. And 2x minus 1, also add 1 to both sides. So 2x equals 6. Divide both sides by 2, and x equals 3. So the solution set consists of two numbers, or two solutions. The solution set is negative 2, 3. There are two values. There are solutions of this absolute value equation. Another example, let's you have two absolute values. If you have an absolute value equation with two absolute values, let's suppose you want to solve the absolute value of 2 minus 3x equals the absolute value of 2x plus 5. Technically, you would have 4 expressions, but it suffices to consider two cases. Okay, so both sides of the equation. So the expressions have the expressions inside the absolute value have both the same sign, either have both the same sign or opposite signs. So we're going to have two cases. 2 minus 3x equals 2x plus 5, or 2 minus 3x equals the opposite of 2x plus 5. Okay, so we're going to solve each equation separately. Let's subtract 2 from both sides. And the opposite of 3x equals 2x plus 3. And let's add, or let's subtract 2x from both sides. So the opposite of 5x equals 3. And x, it's negative 3/5. So negative 3/5 is going to be one solution. And let's solve the other equation. 2 minus 3x equals the opposite of 2x minus 5. Subtract 2 from both sides. So we have what? We have 7, and then add 2x to both sides. The opposite of x, it's negative 7, and x equals 7. And the solution set is negative 3/5, comma 7. So that's negative 3/5, comma 7. Okay, so this is what we did. So now we're going to consider absolute value inequalities. So an absolute value equation in general has two solutions. There are going to be cases when it has one solution or no solution, and we will consider absolute value inequalities. So here's the situation. Suppose that the absolute value of x is less than 5. Some solutions some solutions of this inequality are, so 3 is a solution because the absolute value of 3 is less than 5. 0 is also a solution. The absolute value of 0 is 0. And negative 4 is a solution of this inequality because the absolute value of negative 4 is 4, and 4 is less than 5. And numbers such as um, 6, negative 8, 5, and negative 5 are not solutions. The absolute value of 6 is 6, and 6 is not less than 5. The absolute value of negative 8 is 8, and 8 is also greater than 5. The absolute value of 5 is 5. So 5 is not less than 5, and the absolute value of negative 5 is also 5. So 5 is not less than 5. So the solution set. So the inequality, the absolute value inequality, absolute value of x less than 5 is equivalent to the inequality -5 less than x less than 5. And the solution set is the open interval -5, 5. On the other hand, also, the absolute value of x greater than 5 is equivalent to either x less than -5 and x greater than 5. So the solution set of this inequality is -∞, -5, union 5 to infinity. So let's take a value. Let's take 6. The absolute value of 6 is 6, which is greater than 5. Or the absolute value of -10 is 10, which is also greater than 5. Okay, so when solving absolute value inequalities, we're going to have 4 cases. Okay, case number 1, in the first case, the absolute value inequality has the form u less than a, where u is any algebraic expression. If you have that case, you're going to solve negative a, or the opposite of a, less than u, and u less than a. So you can solve that as a 3-part inequality. In the second case, it's going to be very similar, except that you have the possibility of equality. So you're going to solve the 3-part inequality, the opposite of a less than or equal u less than or equal a. Case number 3. If you have the inequality absolute value of u greater than a, you're going to solve two separate inequalities. U less than the opposite of a, and u greater than the opposite of a. So the opposite of a. I mean, u greater than a. And the solution set is going to be the union of the solution sets of each inequality. In case number 4, the absolute value of u greater than or equal to a, you're going to solve 2 inequalities, u less than or equal to the opposite of a, and u greater than or equal to a. So I'm going to do examples of each case. We're going to solve each inequality. Number 1, the absolute value of x minus 3 less than 3. So if we have less than or equal to, we can treat this inequality as a three-part inequality. It suffices to solve -3 less than x minus 3 and x minus 3 less than 3. Okay, we can do that by, all we need to do is add 3 to all three parts, and 0 is less than x is less than 6. So the solution set is 0,6. Number 2. The next inequality involves greater than or equal to. We're going to solve the absolute value of 2x plus 5 greater than or equal to 7. Okay, so that one involves greater than or equal to. We need to treat this, or we need to solve to separate inequalities, and the solution set will be the union of the solution set of each inequality. So we need to solve to separate inequalities. 2x plus 5 less than or equal to -7, and 2x plus 5 greater than or equal to 7. Okay, so the one on the left, we subtract 5 from both sides, and 2x is less than or equal to -12. Divide by 2, and x is less than or equal to -6. And 2x plus 5 greater than or equal to 7, subtract 5 from both sides. So 2x is greater than or equal to 2. Divide both sides by 2, and x is greater than or equal to 1. The solution interval from the first inequality, from the inequality on the left, is -infinity from a -6 bracket. And the solution interval of the inequality on the right is going to be bracket 1 to infinity. And the solution set will be the union of these two intervals. Number 3. We will solve the inequality absolute value of 3 minus 2x plus 1 greater than 5. Okay, step number 1, we need to isolate the absolute value on one side of the inequality, and then we're going to either separate it or treat it like a three-part inequality. But first, you need to isolate the three-part inequality. So that's an absolute value bar. So we have 3 minus 2x greater than 4. If the absolute value inequality involves greater than, we're going to separate it into two inequalities. And we are going to solve each. Okay, so subtract 3 from both sides. The opposite of 2x is less than -7. Next, we need to divide by -2. And at the moment we divide by something negative, when we multiply or divide by something negative, the absolute symbol reverses. So we get that x is greater than 7/2. And we're going to solve the inequality on the right. Subtract 3 from both sides. So the opposite of 2x is greater than 1. Divide both sides by 2, by negative 2. When we divide by something negative, the inequality symbol reverses. And x is less than negative 1/2. Okay, so the solution intervals for each inequality, the one on the right is 7/2 to infinity, excluding 7/2, and negative infinity to negative 1/2, excluding negative 1/2. The solution set, we're going to write them from left to right in increasing order, or in the order we would have it on a number line. The solution set is negative infinity, negative 1/2, union 7/2 to infinity. In number 4, we are going to solve the absolute value of x minus 2 over 4 less than or equal to 1. Okay, so that inequality involves less than or equal to. We are going to treat it like a three-part inequality. Okay, so let's do that. Negative 1 is less than or equal to x minus 2 over 4, less than or equal to 1. Okay, so let's multiply both all three parts by 4. So we can isolate x in the middle. We're going to multiply everything by 4. So negative 1 times 4 is negative 4, less than or equal to x minus 2, less than or equal to 4. And then add 2 to all three parts. So negative 2 is less than or equal to x is less than or equal to 6. And the solution set is negative 2,6 within brackets. There are a few special cases. For the solutions, special cases, or sometimes they are called extraneous solutions. For example, solve. Let's say you want to solve the absolute value of 6x plus 18 equals 0. The opposite of 0 is 0. So this is only possible if 6x plus 18 equals 0. So once you solve this, you know how this goes. 6x is negative 18, and x is negative 3. So the solution set is negative 3. So that absolute value equation only has one solution. Now, you were trying to solve something like Let's say you wanted to solve 3x minus 5 equals -2. This has no solution. So this one has no solution because the absolute value is never negative, or an absolute value is never negative. Okay, so an absolute value equation does not necessarily have two solutions. It may have only one solution or no solution. With inequalities, let's suppose you want to solve the absolute value of 5x minus 2 greater than -1. This also has no solution. For the same reason as above. No solution because the absolute value of 5x minus 2 is 0 or positive. Actually, well, actually, I made a mistake. I meant less than -1. It has no solution because of that. And on the other hand, if you have the absolute value of 5 minus 10x, let's say this is greater than -1. That one, since an absolute value is always greater than or equal to 0, since an absolute value is greater than or equal to 0, the solution set is already numbers. The solution set is -infinity to infinity. So I'm going to finish this section and chapter with a few examples. We're going to do absolute value models for distance and tolerance. Okay, so I'm going to read this part. That's on page 166. So this is the situation. If A and B represent two real numbers, then the absolute value of the difference, either the absolute value of A minus B or the absolute value of B minus A, represents the undirected distance between them. So we're going to do example 5. We're not going to solve it. We're just going to write an absolute value of inequality. Okay, so in general, either A minus B or B minus absolute value of B minus A represents the distance between B and A. or A and B. Okay, so a statement for, or so an absolute value inequality for the statement K is no less than 5 units from 8. From the context, we know that we are considering the distance between K and 8. So it can be K minus absolute value of K minus 8 or absolute value of A minus K. And it's no less than 5 units from A. That is going to be no less is going to be equal or more. That's going to be greater than or equal to 5. And B, N is within 1,000 unit of 6. So within 1,000 unit of 6, we are considering the distance between N and 6, which could be the absolute value of N minus 6 or the absolute value of 6 minus 8. And is within 1,000 unit. That's going to be less than 1,000. Okay, couple of applications. This is on page 168, number 75. So that's 75 on page 168. So 168. Suppose that y equals 5x plus 1, and we want y to be within 2,000 unit of 6. For what values of x will this be true? So we're calculating the distance, or the statement involves the distance between y and 6, and that must be within 2,000 unit of 6. So that's an absolute value inequality involving less than. That's equivalent to solving the opposite of 2,000, y minus 6, and 2,000. Okay, so we can solve this absolute value. Okay, I'm missing some. Well, that's okay. I'm going to keep doing that. But y is 5x plus 1. So I should have done that initially, but that's okay. I can continue doing this problem. Y is 5x plus 1. 5x plus 1 minus 6. Okay, so simplify plus 1 minus 6, and we have that 5x minus 5 is between negative 2,000 and 2,000. So add 5 to both sides, or to 3 parts. This is what? This is 4.998. Less than 5x, less than 5.002. And finally, divide by 5. 5 is positive, so the inequality symbol doesn't change. And that is going to be for x between 0.9996 less than x less than 1.0004. So they are asking us for what values of x. Will this be true? So this is going to be true. The statement is true. For x in the interval 0.9996, 1.0004. And last example, that's another absolute value inequality. That's number 78. Same page. The temperatures on the surface of Mars in degrees Celsius approximately satisfy the inequality absolute value of C plus 84 less than or equal to 56. What range of temperatures corresponds to this inequality? So we already have the absolute value inequality set up. The inequality is already set up. That inequality involves less than or equal to, so we can solve it like a three-part inequality. Okay, subtract 84 from all three parts. And C is greater than or equal to negative 140 and less than or equal to negative 28. Okay, so what range of temperatures corresponds to this inequality? That's going to be between negative 140 Celsius degrees and negative 28 Celsius degrees. Inclusive, that is, we're including both end values. And I'm just going to write down the degree symbol. And that's it. Okay, so with this, we finished the first chapter. Thank you for listening.